still. This axis is osmolarity. So that means, and graphs are always built where they go low to high. So they increase in osmolarity. So if something gets more salty, you would expect it to climb up on the scale. We use this graph to indicate volume. We kind of split this down the middle and said there's two compartments. There's an ICF compartment and an ECF compartment. I don't know if I did those backwards, but it doesn't matter. But usually the ICF compartment's bigger. So what we're asking you is, we're looking at volume. Volume of the ICF would be from here to here. Volume of the ECF would be from here to here. So if I see a change in this direction with this dotted line, that means I've increased in volume. If I see a change here, that means I've increased in volume in my ICF. So I could decrease the volume by moving this line, or I could increase or decrease. And then if I see changes above here in any direction, that means I've become more salty. So then we look at this and we say, for example, well, if that's our normal, let's just say we start like this. That's our normal conditions, and we start at 300 milliosmolar, and we start at some volume, which I'll say, I don't know, 15 liters here and 25 liters here or something. And that's ICF, and this is ECF. Let's say I take a solution like this, and I say this is 1 liter of a 0.9% solution of sodium chloride. Well, I know, based on my other lecture notes, that this is isotonic. That means it's not going to change the osmolarity. But 1 liter, that's a lot of volume. So if I dump this liter into here, which you always dump it into ECF, what I expect to happen is the ECF should change its volume. It should increase its volume. But I shouldn't change the osmolarity because it's isotonic. The ICF doesn't change, so it stays the same, but the ECF increases in its volume, but we don't change the osmolarity at all. Vice versa, if I take out water and I leave behind salt, I would expect, if this is normal, I would expect now that I've lost volumes in both compartments, but I've also gained in osmolarity in both compartments, because this would be an example of just taking out water and leaving behind salt.